Hello everyone, welcome back to Ameba 2, and today I will demonstrate how to do 3D calculation for your geometries with our topology optimization. And on our example here, we set our constraint on the left hand side of our geometry, and on the right hand side that we set up our load downwards for our geometry. And in between that geometry, we can see a little section of boxes constructed through our pre-processing. In the next following step, I'll be showing you how to achieve this calculation. After we open up Rhino, so make sure our Rhino unit is set to millimeters. We'll press OK. And now we create our geometry to do our pre-processing process for the 3D example. So we'll go to the box tool, create a box, similar to our example. And now we would like to draw a wire over the box. And now we go to the solid tool and we'll click wire cut, select the curve, select the object that we want to cut, and we want to turn on the keyboard yes. And now our geometry has become two pieces, and we use Boolean union to join them back together. And now our geometry is back in one piece and ready for Grasshopper. So open up Grasshopper, go to our Ameba 2 ribbon, select Ameba Geo, drop to our canvas, and type in group, connect to our component, and now we would like to drop down the low 3D surface to our canvas and our support, which is constrained 3D surface, onto our canvas, and connect each one to according to the component descriptions. And over here, we would like to set our load into -2, -1, and -0. And we would like to connect this to z-axis because the force is coming along the z-axis in the negative directions. And now we select our surface to set one group. And now we select our load. In the next one, we'll set the constraint on the other side of the geometry. Click select, click on the surface, press enter. And our surface has been constrained. And now we hover over the pre-processing component, drop it onto our canvas, connect it to our component, and press edit setting. The usual Ameba setting menu will pop up, and make sure topology optimization is in our solver type, and then you can customize your material according to the material that you're using in your project. And we set the optimal parameters as default and press the left and C. Okay, the next step that we would like to connect our previous information to our mesh parting. We select mesh parting, drop to our canvas, and connect this component to it. And the next part, we would like to set up the project name and workspace as usual. Click panel. project name, and connect our workspace according to the project names. And now we will have size of our projects. So now we would like to give it a size range. So over here, we'll type in 72, connect it to our size, and right click, press start. Mesh pattern have been generated successfully. And next, we move on to our solver. Hover back to our Ameba 2 menu, click solver, connect it to our solver, and ready for the displays. Connect to it, open up the window. We'd like to select US Silicon Valley and press start. So after a brief moment of waiting, our calculation result has come back. So now we would like to type in 100 canvas and connect our steps because our calculation went 100 steps and we want to see the final result. And now we would like to hide the preview of these and hide this geometry on top of here. You can see our geometry has been fully generated and calculated through. And now I'd like to turn on our maze graph to see our force distribution of the design. And also we can turn on displacement graph to see how the geometry react to force. In this case, the geometry is quite small. It doesn't have an obvious impact. And let's review our 3D component again. So firstly, we capture our Ameba Geo into our component and we set our load on a z-axis with negative force, and then we set constraint to all the axes on the surface, and we would like to go to preprocessing components and we set up our size, workspace, and project name. In the following steps, we connect to 100 and get our final calculation result back after the cloud calculations. Thank you for watching. Please comment on our forum or YouTube if you have any questions regarding to Ameba 2. Thank you.